In this video, we'll talk about why you can't copy a unique pointer, but you can move it. And that's because unique pointer is designed to have unique ownership, which means only one pointer can manage a resource. If copying were allowed, you'd have two owners of the same resource, which could lead to double deletes and undefined behavior. So let's demonstrate how we can copy. We cannot copy, but we can move. So we've included the memory library and we have a class called myResource with a constructor and a destructor. Then in the main method, we've got some comments to guide us in this video. The first thing we want to do is create a new myResource on the heap and wrap it in a unique pointer. So unique pointer of type myResource. We call this smart ptr1 is equal to make unique. And the data type would be myResource, and object is created on the heap. So the second thing that we want to do is just making sure that I've got no errors there. I'm building my program. Next thing we want to do is show how copy is not allowed and how it would cause a compile error. So I'm going to copy this line and I'm going to give the second pointer the name smart pointer is equal to 2 and say I'm copying smart pointer 1 into smart pointer 2. And let's run. So here we have this error. Now the error says use of deleted function. And what this error really means or trying to say is you're trying to copy a unique pointer, but copy constructor is deleted and you're not allowed to do that. So this line basically fails because unique pointer has no copy constructor. The copying basically is disabled. So the compiler stops you here to protect you from a bug. So let's comment it out so that the compiler is happy again. No, all good. Next, we want to show ownership, how ownership can be moved to smart pointer 2. So I'm going to copy the whole line here. But instead of the copy over here, I'm just going to use the move function to actually move the ownership from smart pointer 1 to smart pointer 2. So let's see how that builds. Looks good. The next thing that we want to do is we want to check if smart pointer 1 is empty, and it should be after the move. So here we'll just write some lines of code. If so after we moved ownership from smart pointer 1 to 2, smart pointer 1 becomes becomes a null pointer basically. So that means if not smart pointer 1 is true, or in other words, if smart pointer does not own a resource, then in that case we want to see out a message saying smart ptr1 is now empty. And a new line and close. So let's just build, making sure we got no errors there. Next, we want to check if smart pointer 2 still holds the resource. So here what we are saying is that if smart pointer 2 owns the object, so let's just change the message. Now owns the object, or we can say the resource. Okay, so that's what we want to check. So smart pointer 2 should by now own the resource. It is not null, so smart pointer 2 is true. So it should print this line. Okay, so let's run the program and just see how it works. And then we'll explain the result. Okay. So here just to show this part, smart pointer 1 is now empty. So exactly perfect because now the resource or the ownership has been moved from pointer 1 to 2. And then we also have this line is if smart pointer 2 owns the object, then we have this line printed out. I also want to speak about why these lines were printed, since we are not using really new and delete, and why the constructor and the destructor were actually called. And that's because make unique, which what we used here, make unique, internally uses new to create the object. Then the myResource constructor runs and prints myResource created. Okay, so internally this line here, make pointer, will call the constructor, which will print this line, basically, myResource created. And let's move to the second part. When main ends, smart pointer 2 goes out of scope. Its destructor automatically calls delete. So the constructor of what do you call it? Make unique, unique pointer, sorry, which then calls myResource's destructor. And so you see myResource destroyed. So the key takeaway from this video is that unique pointer enforces exclusive ownership, and you can't copy it. That would allow two pointers to own the same thing, which contradicts this line. And in point 3, then you can move it using the move function, and this safely transfers ownership. I hope this video was helpful to you, and I'll see you in the next one. Thank you for watching.